midpoint of the centers of those two things? Well, according to the book, it says that the centers of the flower beds are found at points 4, 5 on the grid. So if this was an actual landscaper who was trying to lay this out, he would be using this. And 14, 13. And we want to find the midpoint. Remember, midpoint is just like average. If you forget the formula, think, how do you find the average of something? Okay? You figure out what the midpoint would be on the graph. And remember, there's two coordinates. You got to find your middle of your x's and the middle of your y's. Now, does it matter which one is x sub 2 and which one's x sub 1? No, because you're adding two numbers together. And if you add 5 plus 2 or 2 plus 5, you get the same answer. If you add 2 minus 5 and minus 5 plus 2, you still get the same answer. Okay? All right. My x coordinates, I'm going to add my two x's, which are 4 and 14, and divide by 2. And I'm going to add my two y's and divide by 2. And these are going to be the coordinates of my midpoint. That is where the center of the sprinkler will sit on the lawn. So that's 9, 9. Okay? Fairly easy, don't you think? All right. Oh, okay. Find the midpoint between these two. Negative 5, 6 and 1, 7. Write it down. Please don't do it in your head yet. Caleb, did you get an answer? What'd you get? Okay, you forgot to do something. Look at your formula. And 13 halves. Okay? Don't forget to divide by 2. You're going to add your two x coordinates, which is negative 5 and 1. Divide by 2. Add your y coordinates and divide by 2. Negative 4 over 2 is negative 2, and that is 13 halves. Now you can leave it improper unless you're going to have to actually go graph that on something. You may want to change that to 6 and 1/2 because it would be easier for our minds to grasp that number. Even though it's the same thing, we can count out 6 and 1/2. Okay? All right, and then one more with the midpoint. Find the midpoint of 8, 9, and negative 3, negative 4.5. Sean, what did you get?
2.5, 2.25.
Very good. All right, now let's look how we got that. x plus x, which is a negative, y plus y, which is a negative, and we divide them both by 2. All right, 8 minus 3 is 5, and half of 5, think money, is 2.5. 9 minus 4 and a half is 4 and a half. Think money. You got $4.50. What's half of that? Huh? 225. Since I've been in high school, anytime I'm dealing with anything with a 0.5, 0.25, 0.75, or whole numbers, I always think about money and quarters. My brain can wrap itself around that because I can actually visualize the 4 quarters that make the dollar. So that's just a suggestion to some of you who may be struggling with decimals. You can use that. All right. The next thing is the distance formula. All right, this is a little bit of geometry for those of you who had me in geometry last year. What is that called? It's a specific type of triangle.
Right triangle.
It's a right triangle, okay? Which one's the hypotenuse? The longest one, or the one opposite the 90-degree angle, is the hypotenuse. And the other 2 are called the legs, and we're going to call them A and B. There is a theorem that allows us to be able to find the length of any one of those sides as long as we know the other 2. And it's the Pythagorean theorem, and James is going to tell it to us.
A squared plus B squared equals C squared. C squared equals A squared.
Either way. Okay? And that is absolutely correct. Some guy who's really, really smart, and his name was Pythagoras, sat around playing with right triangles, and he came up with this. I'm sure that's not how it happened, but anyway. The distance formula is based off of this right here. Now, for purposes of just being pretty, I'm going to move my c squared over to the other side. And I'm going to ask you, because what we're going to be doing, the distance formula tells us how to find the distance between 2 points that are not like vertically in line with each other or horizontally in line with each other. We can use it the other ways too, but that's easy. We just count. All right? If I wanted to know from this formula only C, I wanted to get C by itself, what would I do to both sides of the equation? You would take the square root because C is being squared, and that's how you undo it. All right, so if you take the square root of both sides, we say that C, which is the length of this segment, or the distance between those 2 segments, is equal to the square root of A squared plus B squared, correct? Now, normally we would say plus or minus. But here we're looking for an actual measure. Are distance measurements all any and blah blah? Can't talk. Ever negative? No. So in this case, because we're actually looking for the distance between 2 things, we don't worry about the negative. All right?
Why wouldn't the square root cancel out the square?
The square root doesn't cancel out the squares, because let's think about our order of operations. Grouping first. I have to get that answer. It's not the square root of A squared plus the square root of B squared. It's the square root of the sum of A squared and B squared. Okay? There's a difference. That's not 5 plus 7. It's the